Hello everyone. Today we are going to analyze this propped cantilever beam. In this beam, we have uniformly varying load. It varies from 0 in the point B to 60 in the point A. The span of the beam is given as 6 meter. We know that the upward deflection due to RB will be equal to the downward deflection due to the uniformly varying load. In this case, we can use this expression, then we can eliminate EI so that we will get this. Now from the point B and about the point A, we are going to find the movements and draw the bending moment diagrams. In this case, we have to follow left hand side rule. Clockwise will be negative and anti-clockwise will be positive. RB is acting in the anti-clockwise direction so that it will be positive and the distance is 6. 6 into RB, it will be 6RB. The UVL is acting in the clockwise direction so that it will be negative. To find the movement, we have to multiply the area with the centroid distance. We know that it is a triangle. We know the area formula of a triangle, half into BH. Here the breadth is 6 and the height is 60. So this is the area. Now we have to find the centroid distance of this triangle about the point A, that is 1 by 3 into breadth. Here the breadth is 6. So 1 by 3 into 6. When we calculate this, we will get minus 360. Let us enter that. The bending moment diagram due to RB will be in the shape of a triangle, and the diagram due to the UVL will be in the shape of a third degree parabola. Now let us find area 1 x1 bar. We know that it is a triangle. We know the area formula of a triangle, half into BH. Here the breadth is 6 and the height is 6RB. So this is the area. Now we have to find x1 bar. We have to find the centroid distance about the right side. The formula is 2 upon 3 into B. Here the breadth is 6. So it is 2 upon 3 into 6. For area 1 x1 bar, we will get 72 RB. Now let us find area 2 x2 bar. We know that it is a third degree parabola. The area formula is 1 upon 4 into BH. Here the breadth is 6 and the height is 360. So this is the area. Let us find x2 bar. For this parabola, the centroid distance about the right is 4 upon 5 into B. Here the breadth is 6. So it is 4 upon 5 into 6. For area 2 x2 bar, we will get 2592. In this expression, we have found both of them. Let us apply them. In this way, for RB, we will get 36 kilonewton. Now let us apply the rule sigma V is equal to 0 and find RA, RA and RB are acting upwards. So both of them are positive. The uniformly varying load is acting downwards, so it will be negative. For UVL, the total load is the area. We know the area formula of a triangle, half into BH. Here the breadth is 6 and the height is 60. For RA, we will get 144 kilonewton. Now from the point B and about the point A, let us take a moment and find MA. RB is acting in the anticlockwise direction so that it will be positive and the distance is 6. So 36 into 6. The uniformly varying load is acting in the clockwise direction so that it will be negative. For the UVL, we have to multiply the area with the centroid distance. This is the area. The centroid distance about the point A is 1 upon 3 into B. Here the breadth is 6. So 1 upon 3 into 6. Let us assume that MA is acting in the anticlockwise direction so that it will be positive. Finally, for MA, we will get a positive value. That means our assumption is correct. Using the right hand side rule, we can find the shear force values in the point A, and using the left hand side rule, we can find the shear force values in the point B. Here you can see the shear force diagram. In this point, the shear force becomes 0. In this point, there will be maximum positive bending moment in the beam. In this point, let us make a section and find the distance. You can see that in that point, I have made a section at a distance of x from the point B. We have to find this height. For the distance of 6, the height is 60. So for 6, it is 60. But I need the height at the distance of x. So we have to multiply with the x so that we will get the height as 10x. Now let us find the shear force in the section. We know that it is 0. From the point B, we have to find the shear force. Here we have to use the left hand side rule. Upwards will be negative and downwards will be positive. RB is acting upwards so that it will be negative. The uniformly varying load is acting downwards so that it will be positive. For the uniformly varying load, the shear force is the area. Let us take this triangle. We know the area formula of a triangle, half into BH. Here the breadth is x and the height is 10x. So this is the area. Finally, we will get this expression. We can take root on both of the sides so that for x we will get 6 upon root 5. We know that this height is 10x. Now we know the value of x, 6 upon root 5. So 10 into 6 upon root 5, we will get 60 upon root 5. Now let us find the maximum positive bending moment. RB is acting in the anti-clockwise direction so that it will be positive and the distance is 6 upon root 5. The uniformly varying load is acting in the clockwise direction so that it will be negative. For this load we have to multiply the area with the centroid distance. For this triangle, this is the area. The centroid distance about the left is 1 upon 3 into b. Here the breadth is 6 upon root 5. So this is the centroid distance. In this way, for the maximum positive bending moment, we will get 64.4. Using the right hand side rule, we can find the bending moment in the point A. In the point A, we have MA, which is acting in the anti-clockwise direction so that it will be negative. Here you can see the bending moment diagram. In this point, the bending moment becomes 0. This is the point of contraflexure. We can make a section in this point and find the distance. You can see that I have made a section in that point at a distance of x from the point B. We have to find this height. For the distance of 6, the height is 6, but we need the height at the distance of x so that we have to multiply with the x. So the height will be 10x. We have seen it already. Now let us make an expression for the movement in that section. We know that it is 0. RB is acting in the anti-clockwise direction so that it will be positive and the distance is x, so 36x. The UVL is acting in the clockwise direction so that it will be negative. For the UVL, we have to multiply the area with the centroid. This is the area and it is the centroid distance. In this way, for x, we will get 4.65 meter. Let us apply that. Now we are going to end this session. Thank you for watching this video.